Okay, so now we want to find the volume by revolving about the y-axis. Notice this time now that the limits of integration are now from C to D. It is the y values. And the function has to be in terms of y. So it's the exact same thing. The volume is just going to be pi times the radius times the thickness. And remember, the radius is just the y value. So when we revolve, we get a circle. That's why we call it discs. Okay, let's look at the first example for today's lesson. So it says use a disc method to find the volume of the solid generated by revolving the region bounded by the graph of y equals x cubed, the y-axis, and the lines y equals 1 and y equals 8 about the y-axis. So let me show that. It is about the y-axis, so I'm just gonna do this. Now, this is y equals x cubed. Now I'm going to shade the region that is bounded by the graph and the two horizontal lines and the y-axis. So this will be the region right in here. Notice again, there is no gap between the axis of rotation and the region. There's no gap. So let's set it up. So volume equals pi integral. The integral is going to be from this y value to this y value. So from 1 to 8. 1 to 8. And our equation or our function, this one, needs to be in terms of y. So that means we need to solve for x. So let me just move this out of the way. Let me put it over here. There we go. So now what I'm going to do is write y equals x cubed. And to solve for x, I have to take the cube root of both sides, and that gives me x by itself. So now I can plug it in. So let me move this back again. So the function is going to be cube root of y, squared dy with respect to y. Now, what I'll do is, instead of writing it as the cube root of y, I'm gonna write it as an exponent. So pi integral from 1 to 8. Now, y raised to the 1/3 power, but since I'm raising it to the second power, I multiply, so it's really 2/3 dy. So now let's integrate with respect to y. So the antiderivative is going to be, let's see, pi antiderivative 2/3. I need to add 3/3. I'm adding 1, 3/3. So that'll give me y to the 5/3 power. And then I'm going to have to multiply it by the reciprocal, 3/5. And I will evaluate from 1. Okay, so my calculations could be easier. I'm going to get this 3/5 and move it outside. That'll make things way easier. You should do that too. So now it'll be 3 pi over 5. And I have y to the 5 over 3 power. And we're going to evaluate from 1 to 8. So here we go. 3 pi over 5. Then it's going to be 8 raised to the 5 over 3 power minus 1 raised to the 5 over 3 power. Running out of space. 3 pi over 5. Now 8 to the 5 over 3 power, so 5/3 power, means that you have to take the cube root of 8, and then the result, you raise it to the 5th power. So the cube root of 8 is 2. 2 raised to the 5th power is 32. Minus, now 1 raised to any power is still 1. So this is 1. So inside the parentheses, I'm left with, let's see, 3 pi over 5 times 31. And I ran out of space, so I'm going to go this way. Sorry about that. So 3 times 31, that's going to be 93 pi over 5. Okay, next example. This time we want to find the volume by revolving about the y-axis. And it says, by revolving the region in the first quadrant by the graph of natural log of x, the line y equals 2, and both axes. Let's see, what does that mean, both axes? So here we have y equals natural log of x. It's supposed to be over the y, revolve about the y, so that's this. Let me shade in the region so we can see it. It's this one. Notice it is bounded by the function, the line y equals 2, the y-axis, the x-axis, both axes, just like it said right there. So now what we need to do is, since we want to revolve about the y-axis, I need to change this function in terms of y, meaning I have to solve for x. So to solve for x, I have to do e of both sides, so it'll be e to the y equals to x. So that's my function in terms of y. So now let's set up the integral. So volume equals pi integral from here to here. Those are my y values, limits of integration from here to here. So from 0 to 2. From 0 to 2. And then it'll be my function e to the y squared dy. Let's simplify it a little bit. Pi integral from 0 to 2 e to the 2y dy. Let's take the antiderivative. That'll be pi 1/2 e to the 2y. We're going to evaluate from 0 to 2. Just like we did on the previous problem, you can get this 1/2 and move it outside. So let's move it outside. It'll be easier to work with. So if I take it outside, it's going to be pi over 2. And then e to the 4th power, because 2 times 2 is 4, minus e to the 0. And e to the 0 is 1. So pi over 2 times e to the 4th minus 1. Okay, last example for today. So we want to find the volume of the solid generated by revolving the region bounded by the given lines and the curves about the y-axis. Y equals square root of 2. Y equals square root of x, y equals 2, and x equals 0. So let's look at the region. Let's label it. We want to revolve about the y-axis. The region is supposed to be bounded by the curve y equals 2, and x equals 0 is just the y-axis. So let me highlight it. So there we go. Let's change our function in terms of y. So if I have y equals square root of x, so if I want to solve for x, I need to raise it to the 2nd power. If I raise it to the 2nd power, it's going to give me y squared equals to x. So there you go. Let's set up our integral. So volume equals pi, the integral from, let's look at our limits of integration. So it's from this y value, which is 0, to this y value, which is 2. So from 0 to 2, and it's my function y squared dy. Like we've been doing before, let's simplify it. So pi integral from 0 to 2, y to the 4th dy. Let's integrate. Pi y to the 4th. The antiderivative of y to the 4th is y to the 5th over 5. From 0 to 2. Now, I didn't do this that last time. Well, I don't remember when, but the function is being divided by 5. The function is being divided by 5. So we're going to get this 5 and move it outside. But look at it. It's in the denominator. So therefore, outside, it has to be in the denominator too. So it'll look like this. Pi over 5, y to the 5th, from 0 to 2. This is where I check. If I plug in this 0 into y, I'm going to end up getting 0. So I'm going to ignore it. This time I am. Last example I didn't because it was e. But for this one, it'll give me 0. So now it'll be this. Pi over 5. And I have to plug in the 2 to the 5th power. 2 to the 5th power is 32. So my final answer is 32 pi